of the user input. Entities represent the terms or objects that are relevant to that intent that the user provides, and dialogue is the branching conversational flow that sort of is governed by these intents and entities. So in the context of conversational AI, there's several dialogues. There's the chat dialogue, which is an open domain dialogue, sort of it's ungrounded, includes social chit-chat, and personality chat is probably a better tool in order to enable that. Then sort of there's information consumption, what is today's agenda, there's task completion, book me a flight from Cairo to Seattle. And support is build conference, is good to attend. All of these are task-oriented dialogues, they're grounded, they sort of follow certain patterns that are governed, and Lewis and Q&A Maker would be significant tools to enable these types of dialogues. Also, this would work hand in hand with cognitive search, bot framework, and speech. So the language cognitive services intends to build custom models for entity extraction and intent classifications in unstructured data. It is an interactive process that enables guidance through sampling in order to generate sort of machine learning models to do these custom extractions and classifications. It does target individuals with no or limited AI expertise and in problem spaces with have limited or no labeled data. And through a feedback loop, sort of this is maintained and improved consistently, and a fundamental part of this is the efficiency of producing these models. So the foundation sort of for the language understanding cognitive services is a concept called machine teaching, which sort of fits into the realities that in most custom models you have limited labeled data availability. Prior sort of to the current wave of data-based models, sort of rule-based approaches were in expert systems, where you would sort of get a domain expert, they would do an if-then set of rules, and that would govern a very rigid sort of interactivity. Sort of deep neural nets, sort of these types of models that are driven by data that require huge volumes of data, which is not necessarily sort of available in custom models. Lewis has an interactive experience between the machine learning model and the human teacher in order to effectively and efficiently develop this model from a small data set, small labeled data set, leveraging a huge volume of unlabeled data, which is generally sort of the conditions that exist in custom models. So while machine learning is about extracting knowledge from existing labeled data, and deep learning models require large volumes of data, some very sort of detailed machine learning expertise. It assumes that the training and testing data are of identical distribution and has a lot of complex featurization in order to enable these extractions. Machine teaching, or the concepts that have the language understanding based on it, allows you to extract knowledge from the teacher, from the developer. It assumes that there is no or limited labeled data, assumes that the individual developing this has no or limited machine learning expertise, but has domain expertise, has a lot of domain expertise, and the training and testing distribution are not equal. And through simple featurization, you can enable a much more powerful sort of extraction in an efficient manner. And a Lewis application in the course of its design is an iterative process. You start by planning, defining the actions, information, and scenarios, and then you build your schema of intents and entities, you add training examples, and you go through a process of testing and improving your model. Once you're happy, you publish it, you connect it, and then you collect unlabeled utterances that are then used sort of to refine your model in this iterative process as it catches up with the actual data that the users are providing, and adapts to it sort of through this machine teaching concept. As a fundamental part of a language understanding model, you actually need to design a schema. Designing a schema entails defining the intents and entities of this schema. So intents, and usually that is also associated with a domain detection or classification, is through labeling a set of examples as a certain class. And then once you see an unlabeled utterance, you actually sort of determine is it part of that class or not. As the name implies, what is the user looking for, or the action verbs that are associated in the conversation. So things like greeting, confirmation, requesting a vacation, placing an order, or deleting an email sort of subsequently define an action or a verb. Usually sort of people do, again, sort of intents and their domain collectively. So if I have, for example, a movie and restaurants as part of the domains, and everyone has a find a restaurant, find a movie, book, buy a ticket or book a table in a restaurant, you actually sort of do this jointly, this classification. And classification or intent classification considers the words of the utterance, and the intent selection needs to sort of adhere to that fact. And since the word selection sort of are fundamental sort of to your intent classification, you need to pick classes that are discriminative. So if I have two intents, one is I want to request a vacation and the other is asking about public holidays in an HR bot, these would be very distinct. If you go and think of the ways you're going to express sort of these two actions or these two intents, you would find them that it would be very clearly separable. While sort of requesting a paid leave and a sick leave will have a lot of overlap, and in turn, you should actually sort of have an intent is requesting a leave, and the paid and sick leave are entities that you capture sort of with an entity extraction. So unique words are fundamental to avoid ambiguity in classification and making a good classifier. Entities is entity extraction is through sequence labeling, so you would label some sort of a sequence of things. So flight from original city to destination city on a date. So flights from Cairo to Seattle today. And as you see the sequence sort of evolve, you'll be able sort of to associate that with the respective entity. And entities are the elements that you want to take action upon. So they're generally sort of, again, nouns, so dates, types of leave, country, name, all these different sort of types of entities you can sort of leverage. Entities are divided into common entities, which are pre-trained models, and custom entities that do require training. And in most cases, sort of an advanced NLU model would require some form of custom entities to enable it. So Lewis enables you to have non-machine learning entities, including list entities, which is an exact match to a given set of words or phrases. Prebuilt entities such as datetime, they're part of the recognizers that Microsoft has published. So datetime, number, URL, email, also the ones in text analytics, named entity recognizers for city, for person name, are enabled, and you should definitely sort of use them in your models if you are trying to pick up these cues. And you can also sort of have a regular expression entity, which is, again, an exact match to an alphanumeric regular expression. Machine learning entities define a concept, and they are through the machine learning, and you need to put labels for them. You can define roles or sort of functions within a given utterance for an entity, and entities can also come in hierarchies or structures within this entity. So one should use these different entities and in what context. So list entities are suitable for a bounded set of elements that rarely change. So if I'm doing a food ordering bot, so pizza size or payment method would be things that rarely change, and you can sort of quantify the different aliases that come with that. So list entities are appropriate for that. Pre-built entities for datetime, for number, you don't need to label that sort of and have a machine learning entity go and capture them. They are existing as pre-built entities. And regular expression, again, sort of alphanumeric elements such as product codes can be incorporated in that. Machine learned entities should be the default entity for anything. Roles, sort of, so 4 pizzas and 4 cheese pizzas. 4 is a number in both cases, but in this context, it's actually part of the pizza name in the 4 cheese pizza. So you define sort of when things are used in a variety of ways, and hierarchical entities allow you sort of to structure them, decompose them, and do multi-layer parse, and actually even sort of include actionable hierarchies where intents or actions or verbs can be captured as sequences, and in turn sort of you can enable a whole set of other features sort of in natural conversation. So hierarchies group entities together to form a parent-children sort of structure. You can nest up to 5 layers sort of in a hierarchy, and that sort of enables a robust extraction, enables them to cross-fertilize and improve one another. And managing sort of hierarchies that vary, you need to present the model with different forms of how it appears, so things can be present or absent, things can be spaced out sort of with the use of different terms, and you need to provide some of these examples for the hierarchies to be able to learn and generalize. It can enable you to do multi-layer parse and hence reduce the requirements that you have on post-Lewis logic. So remove the mushrooms from a medium stuffed crust pizza sort of is different than to remove the mushrooms and a medium stuffed crust pizza. So this allows you sort of to define the different parsing and define sort of which action goes with which order in the utterance that you see in front of you, which would require a lot and very intense logic sort of post-Lewis if you're doing very flat extractions for that matter. So decomposition is a very powerful tool that is enabled through these hierarchies to do multi-layer parse. Generally, sort of in Lewis, every model is independent of the other, but you can start to sort of relate them using an is-a relationship that defines these extractions. So if I'm doing a food ordering and I define it as a certain cuisine type, be it Chinese, then if I'm able sort of to extract that cuisine type, then that will probably sort of be a good indication that I'm doing food ordering. So you can actually use that as a signal to your classification, or you can sort of use entity extractions as children to other entity extractions to help these extractions. You can provide them as dictionaries or common entities. So using dictionaries, you can enable certain elements to be extracted, or entities that are machine learned that have a very clear and significant enablement for a certain model should also be used. You can define features. Defining features enhances generalization, while sort of Lewis does work as a general platform for all domains, so it has an understanding of terms in multiple domains. If you actually provide it with your preset set of tokens, phrases, this would focus the extraction and allow it to generalize much better, because these are the elements that have more significant. You can define that through dictionaries. You can either use phrase list features that is suppressed in the output. They're used in the machine learning, but not expressed as in the output of the prediction. Or the list entity could be used sort of in the machine learning, but would also sort of appear in the output if they are significant enough and you have use of them in your extractions. Once you're considering designing bots in a multi-turn scenario, sort of you would have people having entity-only utterances. So in a conversation, I'm going to fly to Seattle tomorrow, the bot would generally respond, where do you want to fly from? I'm not going to say I want to fly from Cairo to Seattle tomorrow. I'll just say Cairo. So it will come as an entity-only utterance, and you should sort of model for that in your model. To have these entity-only utterances, no intent, for example, and plug in sort of the different entities there so that you can capture it in a multi-turn conversation. Negative entities also sort of, you need to capture them, so show me holidays in January versus do not show me holidays in January. If you only train on show me holidays in January, then you will not be able to capture that, and in turn also that will not work very well to having them two separate intents. Because they're very common and there will be a lot of ambiguity, but you would rather better off sort of capturing the negation aspect, don't or do not or avoid showing me, for example, as terms, as entities that you would capture, and you would use that sort of in the action or transforming that action to a negation in the output of Lewis. In many cases, you use these Lewis models sort of as enablement through speech. And once you use speech, you use the speech-to-text output in the labeling, so that if there is consistent spans of errors, you would sort of model against them, and you would not sort of have them accumulate sort of over the model that you have using fixated and proper grammar. You also might want to consider sort of modifications or transformations of some of the utterances, since the speech-to-text might sort of dictate a certain structure, for example, 756 or 756, depending sort of on how that expressed using speech-to-text. You'd have to sort of model that this is the way that the numbers would come, and they would not just be a sequence of numbers 756. So you need to sort of do that reverse mapping prior to processing anything sort of in your utterance. In many cases, models can be divided into two main categories. So there's the command and control, which is how we talk to our TVs, how we take to our sort of cars. So we give command, sort of segmented command and control. So turn up the volume, turn down the volume. We segment them, users segment them into defined sort of actions that would be taken. While if you're talking to an agent sort of in a natural conversation, you probably sort of have more liberties in how you're expressing these actions, and you can pile up multiple things in the same sort of request and the same utterance. And in turn, sort of, you can actually sort of use different intent classifiers and sort of use a score in order to try and govern which intents have fired. Alternatively, you can use this concept of entities, which is expressing these actions as entities and capturing them as a sequence labeling within the entity extraction, and using the intent entity pair eventually sort of to dictate a specific action as opposed to just an intent. And that is a more sound approach, especially with conversational bots that use speech as an input. And in turn, sort of, you need to train your model with different examples that include presence and omissions of different intermediate phrases and lengths, and along with these actions and their presence and their absence. Just as the pizza bot sort of was mentioned a bit earlier, the remove your mushrooms aspect is an action on top of a topping. And you can sort of encode it as an entity for that matter. Multilingualism, as you converse with bots, sort of there's different ways of handling sort of multilingual models. So there's an approach that you would actually define a model for every language. So you would have a model for English, a model for French, a model for German, and so on and so forth. And then you would have a gating sort of that is based on the language. This would allow sort of the models to be more focused to that specific language, including sort of the labeling process would be done by native labelers that would better understand it. But the problem is managing consistency across the different languages, since everyone is developed and processed independently. So maintaining consistency once you add something to one model, making sure it appears in everything becomes a nightmare. And it's also not suitable for mixed languages. And once you move away from English, people sort of mix different languages together, more so sort of English with their local sort of language. And this would sort of not fly through the gating, and it would have no understanding of it. So the different models for different languages approach would not suffice in that. You can define sort of dictionaries, multilingual dictionaries, so that the model can train, and use them as features, so the model can train against them in these multiple languages. So if you support 2 or 3 languages, then you put 2 or 3 dictionaries representing these languages inside of the model and learn with them. This would help with consistency, since it will be one model that's trained across the board for all the languages. It also handles mixed languages, but labeling might be a bit more complex because it would span several sort of languages and maybe even dialects that might not necessarily sort of be the proficiency of the labelers sort of across the board. It also sort of enables you to capture slang terms, which are not sort of very formal language elements, but they start to sort of exist in our world sort of as we move forward. So these would be encoded in these dictionaries. How sort of Lewis represents the processing. It represents an utterance using 3 components, so the culture and the associated default elements that come with that culture, the terms that are outside of that culture that you have defined in your examples, assuming the examples are obviously correct. So these would be what we call out of vocabulary terms, and the user provided dictionaries that a user can upload. They can represent key elements, they can represent different languages that sort of is of interest to the user. Words that do not exist in these set are neglected. So if you have a term that is really sort of not expressed in any of these, then it is considered that it is not sort of within the utterance. In classification, there is no notion of semantic similarity. So there is like buy, bought, buying, and purchase are different words. You can sort of, by providing the appropriate set of examples, make the model learn the correlation between these terms, and in turn sort of it can generalize against them in classification. Entities have some notion of semantic similarity, but a very coarse sort of level. So it does sort of enable you sort of to have different flavors of the same term and being able to do the extractions more effectively based on that semantic similarity. In all cases, the data or the utterance is fundamental to this ability to actually do the extractions and do the learning. So Lewis supports several language cultures. Language support includes the basic language understanding. Any culture that is supported comes with that. There is a set of pre-built entities, and you can have full or partial sort of coverage of that, and the pre-built domains, which are nugget-sized Lewis models to do certain productivity functions, and we leverage machine translation and then human verification to enable expanding them to the new cultures and languages that we support. And also similar dialects should be functional if there is something very specific or words that are very specific to a certain dialect. They would appear in the examples and in turn sort of be captured as out of vocabulary. If you want to explicitly sort of define them, then you can define the terms that are distinct to a certain culture and place them in a dictionary and append them to your training. Currently, sort of English is fully supported. You have major support for the pre-built entities, except person and geography for a handful of, two handful of languages, French, Canadian, French, Chinese, German, Italian, Portuguese, Brazil, Spanish, Mexico, and Spain, and Turkish. And partial support, which some of the pre-built entities are supported, and person and geography names are also not supported. For, again, sort of another set of languages, including Dutch, Japanese, Korean, a few Hindi languages, Hindi, Gujarati, Tamil, Telugu, and Marathi, and Arabic. This sort of profile should change as we progress sort of with better integration with text analytics to be able sort of to have these pre-built entities across the board. Also, pre-built domains, they do exist in the majority of the languages that we support. We should be continuing sort of to use translation or language translation to expand them to other languages, and also sort of expand the list of actually sort of these models for the use within a grander application that you can develop. Lewis has an intent limit of 500 intents. It has 1 million list entities divided over 50 parents. You have up to 500 patterns, which are template-based enhancements for intent recognition. You have 100 machine learning entities and 20 regular expression entities that are enabled. Hierarchies can go up to sort of 5 levels, and any utterance has to be 500 characters or less. And a given model would have up to 15,000 utterances as a maximum sort of number of utterances for the model. So Lewis is stateless. Lewis processes every utterance in its own right. It does not keep context from previous interactions. And Lewis does extractions and not resolutions, so it does extract that this is an entity here of potentially this type. It does not need to resolve what that means. So if I want to order a car pizza, it will come and say that there is a pizza type called car, and then I would have to sort of go and either define that sort of for myself, sort of, or look for a process to do this extraction to resolution transformation. Some of the non-machine learning entities can have resolution sort of built in as a byproduct of their own within the limitations that they also present within other aspects, such as exact match, rigidity, and lack thereof of some semantic understanding. Data is fundamental sort of in designing language understanding models. Machine learning models usually associate larger volumes of data with better performance. That is not necessarily the case, and it's sometimes even counterproductive. You have to have utterances with a decent amount of variation to represent the actual usage of your end users. Utterances should include different synonyms, should sort of include grammatical sort of mistakes, if that sort of makes sense in the usage. So to have utterances with only entities and present the different possible ways of ordering terms within an entity extraction. You can have things sort of trailing or leading with that. And that sort of, while sort of there are some of the requirements, you actually don't need to think about it if you actually use actual data which is the best sort of set of data that you can use to train these models. If the case actual usage data is not available, then you can go and collect through crowdsourcing actual data. If that sort of is difficult and no data exists, then you can bootstrap your model using generated data to actually develop or publish this model to collect unlabeled utterances. But you should consider including non-grammatical correct sentences and the following different ways users provide the different forms. Making permutations of structures of entities of different forms where missing or existing entities. Provide utterances and entities with varying length when meaningful, and using variations in many prepositions. This generated data should be used to bootstrap or collect unlabeled utterances to enable it. The schema itself, the intent and entities, is something that is a work in progress. You need to evolve this as you go. Look at the performance that you're getting and make sure that it is capturing what you're looking for. And there's different ways of improving the schema based on the feedback that you're seeing from the examples, from the actual usage of the model moving forward. So this is an architecture, a very simple architecture that uses bot framework along with other cognitive services to enable a conversation. So bot framework provides the connectivity to the different channels. You can connect to things like App Insights, Power BI, and eventually you use language understanding in order to process that, along with Q&A maker, and if you have speech enabled, then speech. And if you're using speech, then this training between the text and the speech and the audio need to be synced together so that the training is consistent on the output of speech. You can also invoke machine translation, so you can piggyback using machine translation to pivot on a specific language if the performance of machine translation is at bar. If not, you can have the multi model with multiple languages, and you can use language detection to get to it. Or you have one model with dictionaries and you forget about translation. It depends on how you design your model. You can plug in sentiment analysis from text analytics. The bot itself retains the conversational memory. So Lewis is stateless. And it connects with different functions, user search, operations, app insights, and the generation can also go through translation and definitely through a speech service in order to provide it back as an audio. In many cases, in IoT models, Lewis can work standalone. You would train the model based on a textual input. And if this IoT device is working on speech, then you need to cross-fertilize the audio speech with the text utterance data to make sure that you're training with the right data set. And then it can feed into your process in order to respond and act accordingly. There is tools for DevOps on GitHub that was published, announced last build, and you should use them. This is an Azure CI/CD pipeline to allow you to work with a continuous improvement of Lewis models, including testing and training your data, and maintaining training data, testing data. In many cases, a lot of people start into NLU and define their model, and they forget about many steps that require attention prior to starting to design an NLU model. I would briefly run through them, but this is a very common mistake, that you design an NLU and then you come to reality and it's not of no use because you've not gone through the actual steps of designing a chatbot development. So the first thing is determining the role of the bot and setting goals, creating the conversational architecture, designing dialogues and storyboards so that you can understand where these models are interacting, what they're looking for, what pieces of entities they should be capturing, what actions they should be dependent on. And then collecting bot data if you're unlabeled and you want to publish first and then collect, and then it's transformed into a feedback loop or active learning. And then you pick the platform and start implementing. and then you implement the dialogue and engineering sort of NLU sort of later on. So all these steps need to be taken prior sort of to actually designing an LU, and in many cases people just jump into NLU forgetting about the other stuff, and in turn they end up in a position that they need to do a lot of rework of their models as the bot starts to mature and grow. In order sort of to implement dialogue sort of within NLU, there's two tools. Sort of the bot framework composer is a UI-driven experience to design and conversational flows. And the adaptive dialogue, again, sort of is just an effort to simplify this sophisticated conversation modeling primitives and allow you sort of to design very interesting interactions with your users. Just to sum up sort of the current work sort of leading up sort of to the end of the year, we should be enabling more semantic or language awareness within the model as private preview, and the batch testing API should come more as public preview. By sort of the first quarter next year, more semantic understanding abilities should be published in public preview. We should deepen the interaction with Q&A Maker, and we should enable customer managed keys CMK experience, and improve guidance sort of once people are starting to build a model. That should happen sort of early next year. And then the later sort of next year, sort of having an evaluation pipeline or dashboard and enabling you sort of to do resolutions and post Lewis logic sort of out of the get-go should be the focus of that period. With that, I thank you. I hope this session was useful, and I would be delighted sort of to have more questions.